Hey United, today we're going to go through exercise 6i on simple operations with surds on page 416 of your textbook. So I'm going to give you a heads up. This is quite similar to what we've done before, but it's a little bit more tricky. Alright, so hopefully you already remember what surds are. Now surds are the numbers inside a square root that end up not being a whole number. So for example, if I have root 4, hopefully you know that root 4 means what number multiplies by itself to gives you 4. Well, that would be 2. Or if I had root 9, I know that what number multiplied by itself gives you 93. But if I have something like root 5, that's a surd because no whole number multiplies by itself to give 5, right? So it'd be 2 point something, something, something. But the idea of a surd is that we can leave it in that form and actually add and subtract them if they are like surds. Right, so like surds is very particular. It's kind of the same as when we're talking about like terms. In this case, instead of writing x, I'm writing root 3. Or instead of writing x, instead of writing y, I'm writing root 7. So it's the same idea. Over here, you can identify that I've got root 3, root 3. Now, those are both like surds. So what I'm going to do is I'm going to pretend as if they were x's. So I had 2x plus 3x. In which case I would just get 5x, right? But now instead of writing 5, I'm going to write 5 root 3. And that's the same idea. Over here, instead of writing root 7, I'm going to write x. I've got 11x minus 2x, and that gives me something like, well, 11 minus 2, which is 9x. Except once again, instead of writing x, I'm actually going to write our surd. So 9 root 7. Over here, you can see that you can't add them if they're not like terms. So root 5 and root 3 are going to be different. It's kind of like if I had x and y, you can't actually add them. So you need to understand that you can only add and subtract like terms, just like with your fractions, where you can only add and subtract fractions with the same denominator. Over here, I've got square root and then squared. Now, understand that square rooting is the opposite of squaring, just like how adding is the opposite of subtracting. If I have a value, let's say 5, and I add 6 and then take away 6, I'm just going to end up with what I began with. It's the same idea. So if I start with a, I square root it and then square it, I'm just going to end up with what I started with. So for example, if I have root of 5 squared, then that will give me 5. So hopefully that makes sense. Now that's addition and subtraction. Let's go ahead and do some examples. So I'm going to look on the left hand side on the bottom over here. Simplify 2 root 5 plus 6 root 5. Now remember, I'm replacing that with an x. So 2x plus 6x would normally give me something like 8x. But remember, I'm not writing x, I'm writing 8 root 5. Okay, same idea for this one, except when there's no value there, it's just going to be a 1. Same as if you had x, it's the same as 1x, right? So I've got 1 root 3 minus 5 root 3. I'm going to treat the root 3 like it's an x. So I've got 1x minus 5x would give me negative 4 up. But once again, I don't write the x, I write root 3. Perfect. Now, with multiplying and dividing, it's a lot more straightforward than addition and subtraction of surds, we don't actually have to have the same like terms. For example, if I have root a times root b, I just put them both, multiply them both inside the surd. For example, if I have root 5 times by root 3, I just have inside root 5 times 3. Okay? And the similar idea for division, if I've got root a divided by root b, I just have root, and then on the inside a divided by b. So for example, root 10 divided by root 5 is just going to be root and then 10 divided by 5, which is root 2. Let's apply that. So on the bottom over here, I've got root 3 times by root 10. So, I've got root 3 times by root 10. So I'm going to follow this formula over here. I'm going to say that that's the root of the two numbers multiplied on the inside, 3 times 10, which is root 30. When I'm dividing, it's just the same thing, but I'm dividing on the inside. So that was A. This one's for B, where I've got root 24 divided by root 8, which is the same as root 24 divided by 8. Now 24 divided by 8 I know is 3, so that ends up being root 3. This one over here is for those of you who are looking to do something a little bit more difficult. So what if I've got a number in front and number on the inside? So what I'm going to do is I'm going to have the numbers in front, the numbers in front to still be in front, so 2 times 5, and then I've got the root 3 times by root 2. So all I've done is I've rearranged some stuff, because remember, this is 2 times root 3 times 5 times root 2. So all I've done is I've put the numbers on the left-hand side, the whole numbers, and then we'll put the surds on the right-hand side over here. Okay? Now what I'm going to do is I'm going to say, well, 2 times 5, I know is 10, so 10. But now I'm multiplying the surds, so it's root 3 times root 2, which gives me root 3 times 2 on the inside of the surd, which is 10 root 6. Alright, hopefully that makes sense. Let me know if you need any help.